Then another attribute by which we classify engines is based on the mechanism of charging. Okay, as I just mentioned, what is charging? It is a process by which fuel air mixture is taken into the combustion chamber of an internal combustion engine and prepare it for combustion. Okay. So, we learn what is called as mixture preparation as we go along, right. So, we need to prepare the fuel air mixture, okay, in the combustion chamber, and the process of charging is a process by which we take fuel and air from, let us say, fuel tank and atmosphere respectively and bring it into the combustion chamber. Okay. That is the process of charging. So, based on the method of charging, we have what are called as naturally aspirated engines and supercharged engines. So, there is a classification based on the method of charging. So, what is this, right? A naturally aspirated engine is one where either the air or the fuel air mixture is introduced into the combustion chamber at near atmospheric pressure. Okay. So, that is a naturally aspirated engine. Okay. Naturally aspirated engine is one where the fuel air mixture or air, okay, is typically introduced into the combustion chamber at near atmospheric pressure. Okay. What about in a supercharged engine, right? Here air typically, okay, or let us say sometimes even fuel is introduced at a high pressure, right. The fuel air mixture, right, is introduced into the combustion chamber at pressure, higher than atmospheric. Okay. So, that is the difference here. Okay. So, what we do is that, like, for example, like we use a device called a turbocharger. Okay. So, we will look at that. So, if you go and buy a diesel powered car today, right, but the chances are that most of them will be what are called turbocharged vehicles, right. So, a turbocharger is a device which will essentially compress air and introduce that air into the combustion chamber of a diesel engine at pressures higher than atmospheric pressures. Okay. And we will see how they work and what are the advantages due to turbocharging. Okay. So, this example is a turbocharged engine. The general term given to such engine is that it is a supercharged engine. A turbocharged engine is a specific example. Okay. So, that is the that is another classification. We will look at both. Okay. So, these are some broad ways in which we classify engines, internal combustion engines. Like as discussed, we are going to look at internal combustion reciprocating engines, and we will look at both spark ignition and compression ignition engines. Okay. And we will also look at 4-stroke and 2-stroke engines. We will also look at naturally aspirated and supercharged engines. Okay. So, that is the broad classification of internal combustion engines. Now, what we will do is that, like, we will go and look at the components of an IC engine. Okay, so we look at what are the typical components, okay, of an IC engine. So to begin with, right, let us consider a 4-stroke engine. We will come back and look at a 2-stroke engine and then like identify in what way a 2-stroke engine differs from a 4-stroke engine later on. To begin with, let us consider a 4-stroke engine. Let us identify what are the components in a typical 4-stroke engine, right. So broadly, if you look at a 4-stroke engine, like you can picturize, like the internal combustion engine into a set of 3 block of components, okay. So let me just draw a very simple block diagram and then we will look at the actual components as they are realized in an engine, okay. So typically we have what is called as a cylinder block in the middle, okay. These comprises what are called as cylinders and pistons, okay. That is where the combustion happens and chemical energy is converted to thermal energy and thermal energy is converted to kinetic energy, okay. That is what is called as a cylinder block. And on top of the cylinder block we have what is called as a cylinder head. So cylinder head contains mechanisms that are used to introduce air, fuel, like into the combustion chamber in the cylinder block, and also mechanisms to control these so called valves, like which introduce air and fuel air mixture, and also they contain the spark plugs in a SI engine, a fuel injector in a diesel engine and so on, okay. All these components are contained in the cylinder head, okay. And the third block of components is below the cylinder block, which we will call as the crankcase. So essentially at the end of the day, like we can see that if we consider a road vehicle, the component that we can see from outside is a rotation of the wheel assembly and the tire. So as we discussed in the internal combustion engine, the thermal energy is converted to reciprocatory motion, right. So kinetic energy, and that is in the realized as a reciprocatory motion of the piston. Now the reciprocating motion of the piston is converted to a rotary motion of what is called as a crankshaft, and then the crankshaft is connected to the clutch, the gearbox and the final drive and to the wheels, okay. That is the path of energy transfer, okay, in a typical engine power transmission. So this component called crankshaft, like is mounted in the crankcase, and in a 4-stroke engine the crankcase also serves as a sump for collecting engine oil. So you have engine oil for lubrication, right, lubricating the components in the engine. So the crankcase also acts as a sump for the engine oil. So even if you park your vehicle, right, so the oil will drip into the crankcase, right, and it will be stored there, and then when the engine is operational the oil is going to be circulated, right, through the engine, and it will go and lubricate various components, right. So the crankcase also performs that function, okay. So these are the 3 broad set of components, okay. So if you consider a typical 4-stroke internal combustion engine, you have the cylinder block in the middle, cylinder head above it, the crankcase below the cylinder block. So now let us go and start looking at what are all the components in each one of them, and then we will go ahead, right. So first I am going to look at cylinder block. And one interesting aspect, like even about this course and the field of automotive engineering in general, and it keeps it very interesting, is the fact that there is always continuous change, right. So, even if you take a petrol engine, there are quite a few number of variants of the petrol engine, right, depending on the manufacturer. The same manufacturer will have various variants of the engine. So, that makes it very interesting to learn this field and keep up to date with the developments that are happening in the field of automotive technology. The challenge that it creates is that like it is very difficult to teach all variants in a typical course. So, what we are going to learn in this course is only the base set of components which are by and large common, like to most of these variants. Okay. So, if you go and look up, I would strongly encourage you to look up actual engines. You will see some small variations, right, from what I am discussing in class, and that is to be expected. Okay. So, that is something which is important for us to remember. So, let us look at cylinder block. Okay. So, let me include this. Okay. So, this is a typical cylinder block. Okay. So, as we can see, I hope it is visible. So, you can see that this is a core mechanical structure which supports the engine's reciprocating components, right, and it needs to also provide lot of structural strength because combustion happens in these cylinders. So, the cylinder block has to provide structural support, okay, because you are going to have lot of say mechanical loads, okay, within quotes, and as well as thermal loads, right, because a lot of heat energy is going to be generated, and you will see that the engine is going to get very hot, right. I am sure you would have realized this in practice also. When you drive your car and park it, right, so you go near the hood of your car, right, you will see the heat radiating out of the engine, right. So, it is going to get very hot. Okay. So, it has to provide structural support to all the components and overcome these loads, right. So, essentially take up these loads, and typically these cylinder blocks are made of cast iron for their strength. Like some manufacturers also use aluminum alloys, like for light weighting and better heat dissipation characteristics and so on. Okay. So, those are typical materials used for manufacturing these cylinder blocks, and in the photograph that I am showing you, you can see that there are 4 cylinders. Okay. So, this is a cylinder, okay, which essentially, as the name indicates, is a cylindrical cavity, and basically doubles up as the combustion chamber. Okay. So, you will see that this terminology is interchangeably used, the cylinder or the combustion chamber, right, in when we talk about engines. And you can also see lot of these water jackets, okay, or the coolant jackets. These are the pathways through which water or coolant, engine coolant, is pumped and circulated to cool down the engine by convection, okay, because we do not want the temperatures to increase beyond a certain range, certain level. Okay. So, there are water jackets or coolant jackets which we typically used. So, that is why there are what are called as water cooled engines, right, and there are also what are called as air cooled engines, right. So, air cooled engines you will see in typical lightweight motorcycles and so on, right. In air cooled engines, the flow of air over the engine cools it, and then we have structural features like what are called fins, which provide you an extended contact area, right, for the flow of air, which ensures a greater rate of heat dissipation through convection. Okay. So, you have fins to essentially enable faster, better heat transfer, right, through convection. So, but typical 4-wheel vehicles, what we are considering will have water cooled engines, because of obvious reasons, right. So, yeah. Okay. So, as we and you can see that like there is a pump which will pump the coolant or the water through these jackets, and the cylinders will contain the pistons, which we are going to look at shortly, and the cylinder head is placed on top of this cylinder, okay, and then using a gasket and then like bolted to that, right. The cylinder head is bolted to the cylinder block, okay. So, that is what happens to the cylinder per se, okay. Now, you can immediately see that the cylinder is going to experience a high amount of mechanical load and thermal load, as we already discussed. Why? Because combustion is something where you generate a lot of heat energy, right, and that is going to result in a tremendous increase in the pressure of the gases due to combustion, due to the heat energy that is released, and that needs to be supported, and the temperature also increases, okay. So, it is extremely important to have lot of structural rigidity, so that the cylinder does not deform even by accident, right, due to the continuous motion of the piston and also all the loads acting on it. We do not want the cylinder to deform, and anyway there is going to be some wear and tear with continuous usage. Now, if you want to essentially correct a deformed cylinder, that is going to be a very expensive process, right, because if the cylinder deforms, right, and goes out of shape, you can see that it is all obviously going to inhibit the motion of the piston, right, inside the cylindrical cavity, and consequently the efficiency of the entire process is going to get affected, okay. And then you need to take out all these engine components and then like do what is called reboring of the cylinders, because during manufacture itself the cylinder block is cast and the cylinder is bored. That means to ensure that the tolerances are very small, right, the manufacturing tolerances are kept to be very small. So, if it gets deformed, you need to rebore, okay, and that is quite an expensive process. So, in order to address that, like we use what are called as cylinder sleeves or inserts. So, what are these cylinder sleeves or inserts? So, they are just an insert like which you can place in the cylindrical cavity, okay, and then make the piston move inside it, okay. So, what you do is that this is what is called as a dry sleeve, okay, or a dry insert, okay. So, what you do is that like you just put it inside the cylindrical cavity, right, and let the piston move inside, that is about it, right. So, because then if this gets worn out, what do? You just take it out, replace, that is it, okay. Why is it called a dry sleeve? Okay, we will shortly understand what is the counterpart of it, and then like why there are two variants, right. So, there is also something called as a wet sleeve, okay. So, which is slightly thicker than a dry sleeve. So, what is a wet sleeve? So, this is a wet sleeve or an insert. So, what happens is the following, right. In a dry sleeve, the sleeve thickness itself is very small and the cylinder still provides the structural support. Okay. A wet sleeve is thicker, okay, and it is in direct contact with the coolant to enable better heat dissipation, So on the outer surface, the outer periphery or the outer periphery area of the wet sleeve is in direct contact with the coolant in the cylinder cavity, right. So the wet sleeve has to provide all the structural support, so obviously it is thicker, right. The drive sleeve does not provide structural support, it is just to take out the wear and tear, but the cylinder still should have material on the periphery to take up the loads, and the cylinder is still in contact with the coolant, okay. So the pros and cons are evident, right. In a dry sleeve it is very simple, okay, you can just simply replace it when it is worn on, whereas the limitation is that like you still need to enable heat conduction through the sleeve, through the cylinder walls, then to the coolant, right. In a wet sleeve that is overcome because the sleeve is directly in contact with the coolant, enabling better heat transfer, but the limitation is that like it is thicker, okay. So if it gets worn out or goes out of shape, you need to replace the entire sleeve, okay. So these are what are called as sleeves or inserts, okay, which are placed in the cylinder cavity. Okay, so I think maybe I will stop here for today, and then like we will continue tomorrow. We will look at the other components of the engine, and then like we will go and learn about engine operation. Okay.